Hey there, so we're going to continue our discussion of functions, and we're going to continue with piecewise functions. So a piecewise function is a function that is defined as different formulas in different parts of its domain. So we're going to start with this function, f of x, and we're going to move down the line. So let me go to our formula. So we're going to first graph f of x equals the function is defined in two parts in different parts of its domain. So 2x minus 5 when x's are less than 2, and 3 minus 1 half x when x is greater than or equal to 2. Depending on how you do this in pre-calculus, I usually graph my two functions separate and then put them together. Some people prefer to put them together right away. So I'm going to just do the put them together right away. And in class, if that was unclear, you can do it the other way, where you graph them first. So I always pay attention to this, what I call the split point, which is at 2. So when x is positive 2, the function splits into two different formulas. So when x is less than 2, so smaller than 2, so on the left side of 2, we look at the line y equals 2x minus 5. So this line has a y-intercept at negative 5. I'm going to go down to negative 5. And I know it has a y-intercept there. And then it has to somehow come to 2. Well, what is at 2? What is the value of this function? So when x equals 2, what is the y value? So y would be 2 times 2 minus 5, which is negative. So at 2 is going to be somewhere over here at negative 1. And notice that it's not included, so it's going to be an open circle. And then I can connect those. I need 2 points to find a line. Once I see that it has a linear degree, it's a line. So at first degree, that's a linear equation, so it's a line. So that's my first part. The next is less than 2, so I'm not including this value. So this is the point 2 negative 1, which is not included. So that's why it has an open circle. Now, as I go to the right of 2, so when it says greater than or equal to 2, I am to the right of 2, so larger. And I look at the description, and this is again first degree, so it's going to be a line. And this line has a y-intercept of positive 3. I'm going to go to positive 3, now this is not to step. But notice that if I start drawing here, it's not going to be a function because it's not going to pass the vertical line. So I need to be careful of that. And I'm only going from 2 and to the right. So I want to find the value of 2. So when x equals 2, what is the y value of this particular formula? So when x is 2, I'm going to have 3 minus 1 half times 2. Well, 1 half times 2 is 1. So it's really 3 minus 1, which is 2. So I'm going to be here at 2. So this is the point 2, 2. And notice that this one is included. It does have the equals. So it's going to be a solid here. And so if you're going to continue to connect that, but we don't want to connect it because then it's not going to be a function. But if you follow that pattern, then this is what the function will look like. We could find another point. We could try to solve this for say equal to 0 and see where we cross the x-axis to find your x-intercept. You could just go along 3, 4, 5, plug in any number larger than 2 and see what value gives you to connect them. So this will be my function. Notice that it is defined as a function, so it should pass the vertical line test. So if you draw a line, vertical line anywhere, you should only touch this, which is why this one is open and that one is. We can have them both open, that's okay. That would mean 2 is not in the domain. We just can't have them both be closed, because then it will not be a function. So let's try another example. The second example I had on that is g of x equals the initial value of x. And you may know this from your algebra or pre-calculus. class that this is in D. So how is this a piecewise function, you might ask? Well, because this is really two functions. This is y equals x is the positive side, and the left side is y equals negative x. And so the absolute value of x as a piecewise function would be x when x is greater than or equal to 0. So when x is positive, the absolute value of a positive number stays positive. So if you go here to 4, the absolute value of 4 is 4. But if the absolute, what is the absolute value of negative 4? If you put in negative 4, the absolute value of negative 4, you will get 4. So it's a positive. And so when x is negative, we want the opposite. We have negative numbers, so we want to the opposite. So it is negative x. So that's how the absolute value is defined as a piecewise function. So it's the combination of the two, y equals x and y equals negative x. So if we apply a transformation, how would the absolute value of x minus 3 look like? And if you know from your pre-calculus algebra class, this means this v is moved over to the right by 3. But what would the piecewise function look like? So that's what I want to know. So the piecewise function would be the absolute value of x minus 3 is equal to, following what we did here, it would be the x minus 3 for what values of x, and it would be the opposite, negative x minus 3 for what values of x. So what do you think? So here it is 0 because the vertex is at 0. Where is the vertex here? Well, this would be a v with vertex at 3, so then this would be a times 3 for x greater than or equal to 3, and negative x minus 3, which we can simplify as negative x plus 3 for x less than 3. In order to be a function, we have to leave one of these with the equals and the other one without. In this case, it wouldn't matter where I put the equals, but I just have to put them. So, on your own, I want you to try, so you try graphing f of x equals the absolute value of x for x greater than or equal to negative 1, and x squared minus 1 for x less than negative 1. So try that, and we can talk about this next time we are in class.